This video is on how to simplify with rational exponents. So if we look at the first three examples here, we have exponents that are fractions and negatives. So before we can do problems like 10, 11, and 12, let's quickly review how do we do problems like this where the exponent's not a fraction. So first of all, remember that this is the base, and you're going to multiply it twice, because the exponent is 2. But because it's negative, the negative tells us to move it to the denominator. So we're going to get 1/9. So that is what we're going to do with example 10. So our review is when you have negative exponents, you're going to move location. So we're going to take 16 to the 1/2, which, remember, this is the index, and this goes inside. So I'm going to write it like this. So the index is 2, that's 1, so we don't need a 1 inside here. So we would have the square root of 16, which the square root of 16 is 4. So we solve it just like normal, but because it was negative 1/2, that 4 is in the denominator, so 1/4. So you're going to solve it like 16 to the 1/2, which is the square root of 16, which is 4, but because the original problem had a negative exponent, that's why the 4 is in the denominator. So if we look at example 11, our base this time here is negative. So if we do a quick review problem here where the base is negative here as well, we're going to do this just like it was -2 to the third power. So the negative tells us it's going to move it. So -2 to the third power is -2 times -2 times -2, which is -8. But because it had the negative exponent here, the -8 goes to the denominator. Now when we write a fraction, we put the negative out in the front instead of here in the denominator. A positive divided by a negative is a negative. So our answer here is -1/8. So now if we take a look at this example here, we're going to do it as if it was -8 to the 4/3. So this is our index. This goes inside or around it. So I'm going to have the cube root of -8, and then the 4 either goes here, inside, or around it. So the cube root of -8, what times itself 3 times is -8, would be -2. And then -2 all to the 4th power is +16. Now, since the original problem here is -4/3, we just did 4/3. So because it was negative, that 16 goes to the denominator. Alright, so example number 12. Here we're going to solve just that 81 to the exponent of the 3/4. So we see it's negative, we'll worry about that later. And I see there's a negative in front. That's just going to get brought down in our final answer. It's just going to get brought down every time. Because that negative is not in parentheses like it is here. So we don't include it. We just bring it down every time. So this is the index. This is the exponent. So we would have the 4th root of 81. And then we'd have 2 to the 3rd power. So now we would do the fourth root of 81. So what number times itself 4 times is 81? Would be 3. And then 3 to the third power is 27. Now this negative again gets brought down because it's just out in the front. So you're going to have that in your final answer. Now let's go back to the fact that our original problem here had a negative exponent. So because it had a negative exponent, we take our answer here, negative 27, and we move it to the denominator. So when we write a fraction, the negative goes out in front because a positive divided by a negative is a negative. So we get negative 1/27. Alright, if we look at our next 3 examples, here you could see that there's a multiplication in between. So when multiplying, we need to add the exponents. So if we remember, we've done this before. So the rule is if the base is the same, we keep it the same, and then we add the exponents. Now why? It's because this is saying 2 times 2 times 2, and this is saying 2 times 2. And there's a total of 5 of them. So that is why we add the exponents. Okay, same thing here. 3 plus 4 is 7, because there'd be 3 here, and then you have 4 here, that's a total of 7. Well, that's exactly what we're going to do here. So the base is the same, so you keep it the same, and then you add 4/3 plus 2/3. Now you have a calculator. You can add 4/3 plus 2/3, but it's actually really easy because the denominators are the same. So 4 plus 2 is 6, and then remember we keep the denominator the same, and then 6 divided by 3 is 2. So we get 4 to the second, which is 16. Okay, so the bases are the same, so you keep the base the same, and then you add 3/5 plus negative 4/5. So again, this is really easy. The denominators are the same. So 3/5 plus negative 4/5 is negative 1/5. Well, we've learned what to do if we have a negative exponent. When something has a negative exponent, we can move it to the denominator. So at this point of this class, we can leave our answer like that. We could also leave our answer like this, because this is the index. So it depends what the directions say. There were no directions here, so either option would be fine. Alright, so example 14 here, the bases are the same, keep them the same, and then we add the exponents. Now you have a calculator, you can enter that in your calculator, 1/2 plus 1/4. But if you wanted to do it by hand, remember we need a common denominator, which is 4. So 2 times 2 is 4, 1 times 2 is 2. So in other words, we have 2/4 plus 1/4. So I rewrote 1/2 as 2/4. So now 2/4 plus 1/4 is 3/4. So we would have x to the 3/4 power. So we can leave our answer like that, or if we want to write this, this is the index, and then the 3 either goes inside or around it. So again, if the directions say leave it as a rational versus leave it as a radical. right, next we're going to talk about dividing. So remember, when you're dividing, the rule is to subtract the exponents. So just as a reminder why, if we had 8 to the 4th, that would look like this. And then if we had 8 squared, that would look like this. And then this divides and makes a whole. This divides and makes a whole. So all we're left with is 2 of them. So we would get 2 if we subtracted 4 minus 2, which is 64. 8 squared is 64. So that's what we would do here. The 3 and the 6 are not exponents, so we would simplify it like a normal fraction. And then we would subtract top minus the bottom exponent. Numerator minus denominator. And then if it's negative, instead of writing x to the negative third, we know that when we have negative exponents, we move it to the denominator. Alright, so let's go ahead and try these here. So when the bases are the same, we keep it the same, and then we subtract 1/5 minus 6/5. Which again, that's really simple for us because the denominators are already the same here for us. So we'd have 1 minus 6 is negative 5/5. And then negative 5/5, negative 5 divided by 5 is negative 1. And whenever we have a negative exponent, it moves to the denominator. And 8 to the first power is just 8. So we get 1/8. Okay, example 16. The bases are the same. Keep it the same. And then we subtract top minus bottom. Denominators are not the same. So we could put that in our calculator and get what 1/2 minus 2/5 is. But by hand, we would need to find a common denominator. Something that 2 can multiply to and 5 can multiply to. So I would use 10. So we'd have 2 times 5 is 10. 1 times 5 is 5. So now we have 5/10 minus, multiply by 2, 4/10. So 5/10 minus 4/10 is 1/10. We could also write that as the 10th root of x. Okay, next we're going to review what if we have exponents outside parentheses and inside parentheses. So we need to distribute, and when we distribute, we multiply. So we need to multiply the exponents. So just like when we learned about exponents that were whole numbers or integers, we're going to distribute this. So it'd be 3 to the 2nd power, which is 9. And then 3 times 2 is 6. So 3 times 2 is 6. And then here we have an exponent of a 1. So 1 times 2 is 2. So we would get 9x to the 6 y squared. So if you forget that you're supposed to multiply, remember that this is saying that there's 2 of these. And then this is saying that there's 3 here, and then 3 here. That would make the 6 right here. And then here we'd have the y, and we'd have 2. And then 3 times 3 is the 9. So when we're doing these problems, if we get confused, make up one that doesn't have fractional exponents to help you remember the rule. So here, I have an exponent on the outside and the inside, so I need to multiply. 4 times 3/2. I'm going to simplify diagonally here. 2 goes into 2 once. 2 goes into 4 twice. And then we'd have 2 times 3 is 6. 1 times 1 is 1. So we would get a to the 6th power. Alright, so if we look at the next example here, we're going to distribute 8 to the 2/3 power. And then here we have exponents, inside and outside, so we need to multiply 6 times 2/3. So 3 goes into 3 once, and 3 goes into 6 twice, and we'd have 2 times 2 is 4, 1 times 1 is 1, which is 4, right here. Okay, so let's go ahead and evaluate what 8 to the 2/3 is. So remember, this is the index, and then the 2 is the exponent inside or outside. So I'd rather on the outside because I like to do cube root of 8. So what times itself 3 times is 8 is 2. And then the exponent, so 2 squared, is 4. So we would have 4x to the 4th power. Alright, last one like this here. We're going to go ahead and distribute. So that's 2 to the 3rd power. And then here we're going to multiply. So 2/3 times 3. 3 goes into 3 once. So we're just left with 2 over 1, which is 2. So we would get x squared. Now we're going to go ahead and multiply -1/2 times 3. So -1/2 times 3 is -3/2. Alright, so we'd simplify 2 to the 3rd power is 8. X squared is just x squared. Then here we have a negative exponent, so we're going to move it to the denominator. So we're going to leave our answer like this at this point in this class. We could also write our answer as 8x squared over the square root of y cubed, because this is the index, which is 2 if there's nothing there, and then the 3 here goes inside or around. Okay, these next couple examples, there is more than one correct way to do them. So if we look at this one, first thing we could do, order of operations says simplify within the grouping symbol inside. So since we have the same bases here, we could start with, when you're dividing, subtract. So 1/2 minus 2. So we need a common denominator. This one's, they both can be 2. So 1 times 2 is 2, and 2 times 2 is 4. So we'd have 1/2 minus 4/2, which is -3/2. So we'd have b to the -3/2. I'll wait to move it until the end. And then we have c to the -1/3. And I'm going to wait to move things at the end because I see this 2 here. And I like to, if something's negative, move it at the very end. So again, you can move it, but I'm going to wait personally because I want to apply this rule now that I distribute the exponent. So I'm going to have 3 squared. And then when I'm distributing, now I have to say that my rule is to multiply the exponents here. So I'm going to have -3/2 here times 2. Which is -3. Now we're going to have 2 times -1/3. A positive times a negative is a negative, 2/3. So we don't need a common denominator when we multiply. All right, now I'm going to apply my rule that if it has a negative exponent, I'm going to move it. So 3 squared is 9. It does not have a negative exponent, so it's going to stay up here. But here we have a negative exponent, and here we have a negative exponent. So we can leave our answer that way, or we could leave it as 9 over b cubed, and then we'd have the cube root of c squared, because this is the index of the radical. So either answer works. Okay, so the last problem here, we have something outside of parentheses. It's kind of like when we have this. When we have something outside of parentheses next to the parenthesis like that, that means 3 times the quantity 2x plus 5. And what we did was we used the distributive property. So we would do 3 times 2x is 6x, and 3 times 5 is 15. So that is what we're going to do here. So we would have this. This is what we're doing. X to the 1/3 times x to the 1/3. So then you'd have to be like, oh, when we're multiplying, the rule is to add. And that's really nice for us because the denominators are already the same. So we get 1/3 plus 1/3 is 2/3. Now we're going to distribute here. So we'd have x to the 1/3 times 2 to the 2 times x to the 2/3. So same thing here, we're going to add the exponents. So 1/3 times, we're going to get a positive, and 1/3 plus 2/3 is 3/3, which 3/3 is the same thing as 1, but we don't need to write a 1 there. And then that's it. We can't add these because we know that when we're adding, you can only add and subtract like terms. So for example, when we have 3x plus 4x, we can add them because they're like terms, 7x. But we can't do 3x plus 4x squared. Can't add them together. So that's how I know not to add these together, because these are different.